I want to talk to you for a minute about number sequences and show you a relationship between a couple of sequences that I like. First of all, I have over here the sequence of odd numbers, 1, 3, 5. If I ask you what the next number in that sequence is, you'll say 7. If I ask you what the number after that is, you'll say 9. And then the sequence of odd numbers continues on in that pattern forever. So when we look at a relationship between numbers like this and then fill in the next number based on the pattern that we see, we're using what's called inductive reasoning. Here's our next sequence. Sequence of squares. First number in the sequence is 1. Next number is 4. The number after that is 9. If I ask you what the next number in the sequence is, you'll tell me 16. If I ask you what number comes after that, you'll say 25. And then that sequence continues on like that with that pattern forever. So this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. The next one would be 16 squared. Now I have this book, the Book of Squares, written by the mathematician Fibonacci in the year 1225. And here's what he says in the very first paragraph. I thought about the origin of all square numbers and discovered that they arise out of the increasing sequence of odd numbers. Then he goes on to explain what he's talking about, but I'll show you what he's talking about. What Fibonacci is saying is that this sequence of squares can be built from the sequence of odd numbers. And it looks like this. 1 is the first odd number, and that happens to be equal to the first square. If I take the first 2 odd numbers and add them, 1 plus 3, I end up with 4, which is the second number in the sequence of squares. Now watch what happens when I add the first 3 odd numbers. 1 plus 3 plus 5, that's going to give me 9, which is the third number in the sequence of squares. One more time, I'll add the first 4 odd numbers, and just like you would think, I end up with 16, the fourth number in the sequence of squares. So Fibonacci recognized this relationship in the year 1225, and that's how he starts his book, the Book of Squares. And it's a very nice relationship because if I add the first 2 odd numbers, I get the second square. If I add the first 3 odd numbers, I get the third square. The first 4 odd numbers, I get the fourth square, so on and so forth. So it's a very nice relationship between those 2 sequences. Now it's things like this that drew me to mathematics in the first place. When I would see a couple of things that initially seemed unrelated and later find out mathematically that there was a relationship between them, I always liked that, and that's something that drew me to mathematics in the first place.